Okay, thank you for taking the time to view my presentation today. My name is Kyle Owens, and the study I will be presenting today was performed by myself and Dr. Andy George at Brigham University in Provo, Utah. The title of this presentation is Influence of Cycle Count, Rate, and Dwell Time during Debulking upon the Compressibility of Dry Carbon Textiles. Okay, so to start, I want to define three important terms for the purpose of this presentation. Understanding these terms will be important in interpreting the results of the study as well as its impact. The first of these terms is the fiber volume content. So what is it? Fiber volume content is basically a measurement of the volume of the fibers in a composite compared to the entire composite volume. In a dry fabric sample, this would mean the volume of the fibers divided by the volume of the fibers and the air. In a wetted out sample, the air would ideally be replaced with resin. Here you can see on the right, this formula is the formula that we use throughout this study to calculate fiber volume content, and why the fiber volume content is important, which I'm going to refer to fiber volume content throughout this study as volume fraction. So just to get that out of the way, when I say volume fraction, I'm referring to fiber volume content. But why this is important is because higher volume fractions generally lead to better mechanical properties in a finished part. Okay, the next term to introduce is compressibility. Compressibility is basically a measurement of what volume fraction a sample reaches under different pressures. The figure on the right shows how compressibility can be used to compare different fabrics and how they reach different volume fractions under different pressures. This measurement can be used in manufacturing to predict thickness gradients during vacuum infusion, and also can tell manufacturers how much closure forces will be needed for RTM or preforming to achieve a certain volume fraction. Last, we want to introduce debulking. Debulking is compressing a fiber sample to try and introduce fiber nesting. An analogy I find helpful to understand fiber nesting is in feather pillows. New feather pillows are fluffy, but as pressure is repeatedly applied to them, night after night, the fibers nest into each other and the relaxed state of the pillow gets thinner and thinner. Composite fibers can work the same way, and debulking acts as that repeated pressure, and it works to help the fibers nest into each other and relax at a higher volume fraction. So this can be done on wet fabric or dry fabrics, and can often improve the compressibility of fabrics in that the sample ideally requires less pressure to reach higher volume fractions in the future. All right, so now that those terms have been defined, I want to introduce the study. In this study, we wanted to look at the influence of different factors in debulking on the compressibility of two different carbon fiber unidirectional weave reinforcements. They were dry samples. The factors we wanted to look at were varying the displacement rates, or the speed at which a pressure was applied and unapplied on a sample, cycle counts, which is basically how many times pressure was applied, and dwell times, which is how long that pressure was held when it was applied. The volume fraction of the samples was measured and compared to the volume fraction of a control sample. To apply the pressure, we use a universal test machine, and here's the setup. The sample was placed on a mold or a test plate, and the pressure was applied from above. Pressure sensors were used to maintain a constant pressure during dwell times as the fibers compressed. So this is the machine that we used. And to analyze the different factors in debulking, we use three different debulking techniques or tests: a fast debulk, a medium debulk, and a measurement debulk. And I'll explain those now. Okay, so the fast debulk consisted of fast oscillations of 100 kilopascals of pressure and then immediate relaxation of pressure back to zero pressure. As you can see in this figure, as the pressure is applied, which is this orange line, the thickness of the sample decreases, which is this blue line. Then it increases slightly every time the pressure is let off. The average thickness of the sample decreases slightly with each cycle. So you can kind of see that the average thickness of the sample slowly decreases throughout the debulking. Each cycle lasted roughly 3 seconds. And so that's the compression, the hold, and then the decompression. And that is the fast debulk. Next, we want to introduce the medium debulk. The medium debulk was the application of 100 kilopascals at a constant, somewhat slower displacement rate and then a dwell time of 5 minutes, and then a slow release of pressure. The cycle time for this technique was 6 minutes. And you can see similar trends in that as the hold was applied, the thickness of the sample decreased and decreased until the pressure was taken off, and the sample thickness increased again and went back down. But the average sample thickness is trending downward throughout the debulk cycles. Okay, last was the measurement debulk, which was designed to replicate vacuum infusion here in Utah, as it was the quick application of 85 kilopascals, and that's the ambient pressure here in Utah, holding that pressure for about a 15-minute dwell time and then very slowly releasing that pressure. This generated cycle times of about 25 minutes. And you can see the same trend on the fabric for this one, although it's a very slow one cycle. Okay, so here I'm going to outline the use of these techniques on the samples. First, both sample 1 and sample 2 were subjected to the fast debulk test, with sample 1 going through 60 cycles and sample 2 going through 240 cycles. The measurement debulk test was then performed on all 3 samples, including the control sample, and the measurement debulk was actually performed on the control sample 3 times in succession that day. A couple of days later, the measurement debulk test was again performed on sample 1 and 2 to analyze how compressibility of the samples changed as they had time to relax. And then next, the measurement debulk was performed on both samples. Excuse me, not the measurement debulk. The medium debulk was performed on both samples, with sample 1 being subjected to 5 cycles and sample 2 being subjected to 10 cycles. A final measurement debulk was then performed again on each of the samples. Samples 1 and 2, the control sample did not get an additional measurement debulk at this time. And I'll talk more about these. So in each test though, force and extension were recorded at 10 Hertz. Force was converted into pressure and the extension was converted into sample thickness, H, which was used to find the volume fraction. Okay, so in the next couple of slides, I will show the behavior of the samples during these tests. This test shows the volume fraction of both the samples throughout the fast debulk. You can see that the volume fraction increases as the cycles grow higher, with sample 2 reaching a higher volume fraction due to the increase in cycle count, or the higher cycle count. Next, we'll look at the medium debulk, which shows similar results. But one interesting thing to point out is sample 2 seems to show higher compressibility here, or an increase in compressibility, in that it reaches higher volume fractions at the same pressure as compared to sample 1. Okay, so now we want to review the measurement debulk test results. For each of the cycles, the volume fraction increases quickly as the pressure is applied, and we'll look at cycle 1 here. And then it continues to increase as the pressure is held, which is where this horizontal section is, and then slightly decreases as the pressure is released at the end of the test. These numbers will be discussed in more depth later, but it's interesting to see here that the final volume fraction of the sample is lower from cycle 1 to cycle 2. So you can see here the blue is slightly ahead of the orange, and showing that fiber nesting relaxed somewhat in the days between the first and the second measurement debulk after the fast debulk had been performed. I want to note here that a model was fit to the data for the purpose of compressibility characterization in this study, but the results of the fit were really inconclusive, and so that we didn't discuss them very in depth, but the data fits can be seen here as the black dotted lines. So that's what those are. Okay, so for sample 2, the results are largely similar to sample 1, as the fibers relaxed somewhat between cycle 1 and cycle 2, and showed a greater improvement after the medium debulk. And the medium debulk took place before this gray, the third cycle, just as a reminder. Last, we'll look at the control sample, which improved in each measurement debulk, which was expected as the sample wasn't given significant time to relax between tests. And again, we'll look at these numbers more in depth here in a second. Okay, so here we can see those numbers. We can see clearly the volume fractions of samples throughout the measurement debulk tests. While the fast debulk seems to have resulted in a higher volume fractions for both sample 1 and sample 2 compared to the control sample for the measurement debulk, and those are these numbers right here. The relaxing the fibers actually resulted in sample 1 having a lower volume fraction than the control sample, despite sample 1 having been subjected to the fast debulk. So you can see here, after a few days, sample 1 actually reached a lower volume fraction even with the 2 measurement debulks than the control sample that only had the 2 measurement debulks and not the fast debulk. After the medium debulk, the control sample and sample 1 reached the same final volume fraction maximum, with sample 2 reaching a volume fraction of roughly 4% higher than the control. So pretty interesting results, and I'll leave those up for just a second so that you can observe those. All right, so now I'm going to move on to discuss what they mean. Okay, so first off, it seems like the fast debulk test was ineffective in proving peak volume fraction unless it was performed immediately prior to vacuum infusion. If the fibers were left to relax, the test had little effect in improving volume fraction and actually could result in the fibers, the way that they're laying out, to become unnested rather than showing improved nesting and improved compressibility. The medium debulk did seem to result in better improvements in volume fraction. This suggests that longer dwell times and or slower displacement rates improved fiber nesting and compressibility in the sample. I think that this is further suggested in looking at the increase in compressibility in the control sample alone, as it reached the same volume fraction of sample 1 with its long dwell times and slow compressions in the measurement debulk test that it was subjected to, without going through either the fast or medium debulks. And again, just to go back, these are after all the tests had taken place, this sample 1 had all 3 measurement debulks, but they were spaced out, and it had also been subjected to the fast debulk and the medium debulk. You can see that it reached the exact same volume volume fraction as the control sample. And so this kind of suggests that those additional debulking were not effective in creating a higher volume fraction, where sample 2 was subjected to a bit more debulking, and it did show some improvement. Let me go back to this. So how can manufacturers use this? Well, further testing would be needed to confirm these results and build on them, as this was just a very small sample size. These results do suggest that while debulking in these ways, specifically the medium debulk method, can be effective in improving volume fraction and fiber compressibility. But the time and cost related to performing debulking on the samples may not be worth the small increase of volume fraction in all circumstances. So this is something that manufacturers are going to have to weigh out. If they are able to do these debulking techniques immediately prior to manufacturing, it may be a benefit, but the additional time and cost of performing these may not benefit depending on their purposes. So that concludes my presentation. I want to thank you for giving me the chance to present. It's been a great learning experience for me into the research process, and specifically into debulking techniques. I think I learned a lot from this study, and it has fostered in me the desire to continue to learn and grow and participate in research. So thank you for your time, and have a great day.